Here we go to Iqraa, and in this particular session we will see how to find inverse of a matrix. Does anybody know what is an invertible matrix? Yes, student B. Sir, a matrix is invertible if it is non-singular, that is the determinant of the matrix is not 0. Perfect. Yeah. If a matrix is non-singular, that the determinant of A is not 0, then that particular matrix is invertible. Okay. So we'll see how to find inverse of an invertible matrix. And we have seen before that A inverse is adjoint of A upon determinant of A. And if determinant of A is not equal to 0, then my A inverse will exist and vectors will be invertible. So let's take an example. I have an example here, and if I want to find the inverse, so I need to find the adjoint of A. And what is an adjoint of A? We know that it is the transpose of the cofactors matrix. So let's see what are the cofactors. For the first element, this particular element, the cofactor will be 4. So I put here 4. Then for this element, the cofactor will be minus of 3 because we have alternate plus minus, so I get minus 3 here. Then what about element 3? This element, the cofactor will be minus of 2, and for this the cofactor will be plus 1, so I get here plus 1. So if I take the transpose, I get here 4 minus 2 minus 3 minus 1. I exchange the rows and columns. Then I need to find now determinant of A. So what is determinant of A? 1 into 4 minus 2 into 3. So I have here 1 into 4 minus 2 into 3 is equal to minus of 2. Okay. Now what will be my A inverse? Adjoint of A upon determinant of A. So I have this whole matrix adjoint of A and I divide by determinant of A. So what will happen? This 4 upon minus 2 will becomes minus 2. Then this will 3 by 2 and 1 minus 1 by 2. So here I get the inverse of this matrix. So this was a very easy method to find inverse of matrix, adjoint of A upon determinant of A. Okay. Now we have another method, and you always have a 6 marks question in CBSE exam using this method too, that is the elementary transformations. So this method is used using elementary transformations. And what are elementary transformations? We will see in detail. And there are 2 types of transformations. One is the transformations, the row transformations, and second is the column transformations. And I will be doing some certain operations on the rows and columns, and those operations and columns are called the row transformations. And whenever I applied any transformation on a matrix, I get a new transformed matrix, and that matrix is called the equivalent matrix of the original matrix. So we'll see, actually there are 3 elementary row transformations and 3 elementary column transformations. So we'll see one by one. The first transformation is that if I exchange the row and column, if I exchange 2 rows, then that is called elementary row transformation. We see an example here. I have a matrix here with a 3 by 3 matrix, and if I exchange my first row with the third row, so what will happen? My first row, this 1 2 5, and my third row, I can exchange this. So this row will go up and this row will come down. So I will have 1 2 5 down and 7 9 0 go up. So my 7 9 0, it has gone up, and my 1 2 5, it has come down. So I have got a transformed matrix, and these matrices are called equivalent matrices because I have applied elementary transformation and I got this matrix. So I say that this matrix is equivalent to this matrix. We use the term equivalent whenever I have applied a transformation on a matrix. Similarly, I can apply a column transformation, and if I exchange 2 columns, for example in this case if I exchange my first column with my second column, so what will happen? This is my second column, 2 4 9, it will become my first column, and my 1 3 7, this will become my second column, 1 3 7. So I have applied transformation, I got a new transformed matrix, and this is called still an equivalent matrix of my original matrix. So this was my first transformation where I exchange any 2 rows. any two columns. Okay, so this was the elementary transformation. And the next transformation is if I multiply any row with any number. Suppose I multiply second row with number 5, I got a new matrix and that will be an equivalent matrix. For example, in this matrix, if I multiply my first row with number 6, so what will happen? My first row is this 1, 2, 5. If I multiply by 6, so first element will be 6, second element will be 12, and my third element will be 6 into 5, 30. So I got a new matrix and this is still an equivalent matrix to the original. Similarly, I apply transformation on the column, and if I have this, if I multiply this whole second column with 1 by 2, what I will get here? I will get here, the other columns will remain the same, and this will become 2 by 2 become 1, 4 by 2 become 2, and 9 by 2 becomes 9 by 2. So this is also an elementary transformation where I multiply any row with any number or any column with any number. And the third transformation is that if I have any row and if I multiply any number with any other row and add to that particular row, that is also an elementary transformation. For example, if I have this matrix and I apply the transformation that I multiply 2 with my second row. This is my second row. I multiply 2 with my second row R2 and add to R1, and I apply transformation to the R1 only. So my R1 will become R1 plus 2 times R2. So what is my R1 here? I have 1 here. Then I multiply 2 times R2. So 2 into 3 is 6. 6 plus 1 becomes 7. So I will have here, I multiply this whole row by 2 and I add to the first row. So I will have here 7. Similarly, 4 into 2 becomes 8. 8 plus 2 becomes 10. So I have a 10 here. And then 6 into 2, 12 plus 5, I have a 17 here. So this is an elementary transformation. Again, I can do similar operation on the column. For example, if I have this matrix and I apply this transformation that I multiply minus 3 to column 1 and add to column 2, and I have applied this transformation to column 2. So what will happen? My column 2 will become, I have multiplied actually minus 3 here to this. So 1 into minus 3 plus 2, I get minus 1. Then minus 3 into minus 3, minus 9 plus 4, minus 5. And minus 3 into 7, minus 21 plus 9 is equal to minus 12. So I got a transformed matrix which is equivalent to the original matrix. Now using these elementary transformations, there are only 3, remember, only 3 transformations, and remember particular transformations. We cannot have any extra transformations, only these 3 particular transformations. Using these 3 transformations, I can find inverse, and I show you what is the method to find the inverse. So let's just revise the elementary transformations and try to remember. One transformation is that I can exchange any 2 rows and any 2 columns. Second is that if I multiply any number with any row or any column. And third transformation is that I multiply any number with any row and I add to any row, and the row will become Ri plus K Rj. Similar transformation on column. Okay, now see the procedure to find inverse using elementary transformations. See the method for this. First I write A is equal to I into A. Can I write A is equal to I into A? Yes, student B. Student A. Sir, if I multiply identity matrix with any matrix, the matrix remains same, so I can write A is equal to I into A. Okay. So the method is to apply simultaneously elementary transformations on matrix A on the left hand side, because I have matrix both on the left hand side and the right hand side. So what I will do, I will apply a transformation on matrix A on only on my left hand side. Okay, then I will apply simultaneously similar transformation on my identity matrix on my right hand side. I have a matrix I on my right hand side. So what I am going to do, I am not going to touch this matrix at all. This matrix A will remain as it is. I will apply similar simultaneous transformations on matrix A on my left hand side and I on my right hand side. And what is my purpose? My purpose is to transform this matrix A into identity matrix. See, such that A on my left hand side becomes I. See here, I have A into I into A. Then I apply simultaneously similar transformations both on A and I. And what will happen? My purpose is that the A becomes I. So what will I becomes? I will become a new matrix because I will apply some transformations on I will become a new matrix, and then I is equal to B into A. Now, tell me, what will be my B? I have I is equal to B into A. What is my B? Student B? Sir, we got I equal to B into A. It means B should be A inverse. Yeah, exactly. B should be A inverse. Because we know that A inverse into A is equal to I, so B is my A inverse. Okay, so what actually we found? We found B, and B is nothing but the inverse of the matrix. So using transformations, we thus obtain inverse of a matrix. So we'll see an example to find this. So here the example is, we take the similar example 1, 2, 3, 4, and we use the elementary transformations to find the inverse of the matrix. So let's start. I will write A is equal to I into A. I will not touch this A at all. In fact, I will need not write A as it is. I will just write A as a symbol, and then I will write A matrix here. So my matrix is 1, 2, 3, 4. My identity matrix is, I will write 2 by 2 identity matrix, so 1, 0, 0, 1, and I will write A as it is. Now I will try to make this matrix as identity matrix. So what transformation should I apply? Like, okay, let's start with row transformation. And one thing I need to tell you, that if you are applying row transformations, then throughout apply only row transformations. You should not apply column transformation at all. And if you are applying column transformations, then throughout apply only column transformations. You cannot mix row transformations and column transformations. I repeat, if you are starting with row transformations, you end with row transformations. Throughout, there should not be a single column transformation in any of the operations. Okay, so we start with row transformations, and we know that if we want to make identity matrix, this should become 1, this should become 0, and this should become 0. And the best practice is to make zeros before we make 1, because we can anytime make 1, so we should try to make 0. So tell me, if I want to make this matrix, this element 3 as 0, what transformation should I apply on my row 2? This is my row 2, and what transformation should I apply on row 2 so that this 3 becomes 0? Anybody? Yes, student J. Student E? Okay. Sir, if I multiply R1 with 3 and I subtract from with R2, I will get 0. Okay, that's true. Because I have only 2 rows, I have no other option. So what I will do, I will multiply this whole R1 with 3, okay, and then I subtract from this, so this will become 0. So R2 minus 3R1 is my operation, and when I multiply with my first row with 3, I get here 0 here, and 3 into 2 is 6, and 4 minus 6 is minus 2, so I get a minus 2. Now I will apply similar transformations on my identity matrix. So if I multiply 1 by 3, I get here 3 here, and 0 minus 3, I get here minus 3. Okay. And what about here? If I multiply anything with 0, it remains 0, so this will remain 1 only. So I will have minus 3, 1 as my matrix. So let's see what will happen. I'll get 1, 0, minus 3, 1, and I read and just write A as it is. Now what next? I told you that the best practice is to make the element 0. So I need to make now this as 0. So what transformation should I apply? Okay, anybody? Student A? Sir, I have 2 on my first row and minus 2 on my second row. So if I just add R1 plus R2, this will become 0. Perfect. They have no other option, so I just add R1 plus R2. So what will happen? This 2 plus minus 2, this will become 0. Okay. So what will happen? I have this will 1, this will be 0, this will because this means 1 because if I add 1 plus 0, I will have still 1, so not a problem. And if I apply similar transformations on this matrix, so 1 plus minus 3, I get here minus of 2. So I will get minus 2 here, okay. And 0 plus 1, 1, I get 1 here, okay. So I will get here minus 2, 1 and minus 3, 1 in my second row and A. Now what next? Now I have already got all the zeros here. I got 0 here, I got 0 here. Now I try to focus on this element and want to make it 1. So the best way is to divide by minus 2. If I divide my second row by minus 2, I will get 1 here. So I will divide my second row by minus 2 and I get here 1, 0, 0, 1. What will happen to my matrix on my right hand side? This is my matrix. If I divide by minus 2, this will becomes minus 3 upon minus 2 and this will become 1 upon minus 2. Okay, so I will have 3 by 2 and minus 1 by 2, and this is my inverse because this thing has become I, so this thing has become A inverse. So my inverse of the matrix is minus 2, 1, 3 by 2, minus 1 by 2, and we obtained similar matrix before also using the formula adjoint of A upon determinant of A. So here we got this. Okay, I have solved using row transformations. Okay, now the exercise for you is to solve using column transformations. So all of you now try and solve using column transformations and show me that whether you have obtained the similar matrix or not. And remember, there are many chances of error. There are chances of making mistakes. If you have made a wrong calculation at any of the steps, then all the remaining steps will be wrong. So you have to be very careful in doing these calculations. Okay, now start. Okay, has anybody completed? Yes, Ranjay. Okay, show me. So how did you start it? I wanted you to use column transformations. Sir, I have written A is equal to I into A, correct? Okay, then I have written the matrix A, okay, and I into A. Then I applied the column transformation and I wanted to make, I was trying to focus and make the element 0. So I operated on the second row, second column, and I made C2 is equal to C2 minus 2C1, so that my the element of my first row becomes 0. So this becomes 0, and then I get here the last element becomes minus 2. And I applied similar transformations on my identity matrix on my right hand side. So 0 minus 2 becomes minus 2, and 1 minus 2, 1 minus 0 into minus 2 remains 1 only. Okay, now what next? Then 1 in 1 0, and I have 3 and minus 2 on my second row. So I wanted to make this 3 as 0, so I applied my transformation C1 equal to C1 plus 3 by 2 C2, so that my 3 becomes 0, and I applied similar transformation on the matrix on my right hand side. Okay, then I got here minus 2. So what I did, I divided the whole column C2 by minus 2, and I got this matrix minus 2 1, 3 by 2 and minus 1 by 2. Okay, correct. So and you obtained the similar matrix, so you applied all the transformations on the column. So I hope you have all understood and enjoyed this lecture. Thank you.